Hello future pilots, let's start the next chapter of instrumentation, which is the radio altimeter, or we can say the radar altimeter. So the first question you should ask is that what is a radio altimeter? A radio altimeter measures the actual height of an aircraft above the ground, not above sea level like a normal altimeter. So what is the difference between pressure altimeter and radio altimeter? So in pressure altimeter, it uses the pressure to show us the altitude above the set datum. So for example, if we set QNH, it will show us the altitude above mean sea level. But whereas in radio altimeter, it uses radio signals to know the exact or the actual height of the aircraft above the ground. So the next question that should come to your mind is that what is the use of radio altimeter? Because we already have pressure altimeter, right? So what is the use? A radio altimeter has three crucial jobs. First, it shows pilot height above ground level, which is very important during landing. So I'll explain you how it is important. So if you look at this simulation, this aircraft is on final approach and you can see that the visibility is very low, right? And we know that how much important it is for the pilot to know the height above the ground, because what if there is any building in front or any terrain in front, it can cause collision, right? So to avoid any disaster, radio altimeter was introduced because it measures the actual height of an aircraft above the ground. Next statement states that it helps with automatic landing. So we can say that radio altimeter works with ILS, which is Instrument Landing System, or MLS, which is Microwave Landing System, for autopilot. As during low visibility conditions, the pilot uses Instrument Landing System to land the aircraft. And this ILS works with radio altimeter to know the actual height of an aircraft above the ground. Next point says that it powers the ground proximity warning system, which prevents controlled flight into terrain. So what is GPWS? GPWS is ground proximity warning system, which is fitted in the aircraft, and its function is to prevent collision of the aircraft into terrain. So this GPWS uses radio altimeter to get the information, which is that the height above the ground. So very important question that should come to your mind is that how does radio altimeter works? So let's read about it. Aircraft sends radio waves straight down to the ground. So this is an aircraft and this is the ground. The aircraft sends radio waves straight down to the ground. Alright, you can see here, and the radio waves bounce back to the aircraft. So this radio wave which is sent down straight to the ground, it again goes back to the aircraft. So we can say that there's a transmitter and a receiver in the aircraft in this position or location, we can say. System measures the time taken for the round trip. So as the radio signals are now sent to the ground and goes back to the aircraft, the time that it takes, it is measured by a system. So basically what the system do is it calculates the time taken by the radio wave to reach the ground and also bounce back from the ground to the aircraft. So if we divide the time by 2, we can get the time taken by the radio wave to reach the ground, right? And we also know the formula, which is speed equals to distance by time. So we already know the speed. The speed of radio waves is the speed of light, right? And we also know the time right now because from the system it measures the time. So from there we can get the distance. And what is the distance? Distance is actually the height above the ground. So now we know how the radio altimeter works. So let's now talk about the radio wave, which is frequency modulated continuous wave. Instead of sending one frequency, the altimeter is constantly changing frequency. Starts at 4300 MHz and it increases frequency by 50 MHz and then it decreases by 50 MHz, and this happens 300 times per second. So let me explain. So as you can see here, the aircraft, the transmitter, the receiver and the ground. So the aircraft first sends the signal in 4300 MHz, as you can see, and then it receives at 4300 MHz, right? And then again it's transmit, as it is written, increases frequency by 50 MHz. So now it sends 4350 MHz and then it again receives at 4350 MHz. But what is the reason of continuously changing the frequency? The reason is that the transmitted signal and the received signal will have different frequency. As you can see, this has a different frequency and this has a different frequency, right? And thus the transmitted signal and the received signal will not interfere with each other. And the main reason behind changing the frequency every time is that this frequency difference tells us the height. So next is the frequency band. So the radio wave uses super high frequency band, which is 4200 megahertz to 4400 megahertz. You have to learn this. And in older system, it used the radio wave used to use ultra high frequency, which is 1600 megahertz to 1660 megahertz. The sweep range is plus minus 50 megahertz. We have already read in the previous slide, right? And it happens 300 times per second. You have to learn this. So let's now study about the antenna system. So we already know about the transmitter antenna and the receiver antenna, right? So let's now first talk about the transmitter antenna. It is flush mounted horn antenna on aircraft's belly. So of course it won't be on the belly, right? Because it wants to send the radio wave straight down to the ground. Next point states that it sends elliptical or conical beam downwards. But why elliptical or conical? Because it gives a wide enough to work even when the aircraft is pitched or rolled. Pitch plus minus 30 degrees and rolled plus minus 60 degrees. Next one is a very important point. Here it is written, it always measures the shortest path. So as you can see from the image, it will measure the distance, the shortest distance, because it is very important for the pilot to know the shortest distance, the shortest height above the ground, right, to avoid the collision. So let's now talk about the receiver antenna, separate antenna, also on belly. So of course it should be on the belly only, right? Because it detects the signal which is coming from the ground to the aircraft. And it also should be separate, right? Because we don't want the transmitter signal to interfere with the receiver signal. And thus this is the reason the transmitter antenna and receiver antenna has both separate antennas. The next point states that it must be positioned away from transmitter to avoid interference. So of course it should be in a distance, right? So as you can see from here also, it is in a distance, because to avoid any interference with the transmitter signal and the receiver signal. The last point states that it is similar design to transmitter, as you can see from here also. The power it uses is about 1 watt, which is very low power. Next we are going to study about the parts of the radio altimeter. So let's now look at the instrument. So if you look at the instrument closely, you will realize that from 0 to 500 feet they have expanded scale. That means it is very easy to read. And from 500 to 2500 it has compressed scale, and means that it has less detail. So we can say that the logarithmic scale is not linear because it changes after 500 feet. So here you can see a yellow mask. But what is the function of this mask? So the pointer disappears behind this mask. But when does this happen? So when the height of the aircraft above the ground is more than 2500, this pointer disappears and it goes behind this mask. And also when the equipment is switched off, and even if there is any fault in the system, the pointer will again disappear. So what is the function of this low altitude warning light? So it illuminates whenever the aircrafts fly below the preset height. Alert tone sounds from 100 feet above decision height, and this tone gets louder as it descends. And as it crosses the decision height, the tone stops. Next, if you see here, there is a flag alarm. So this is a warning flag, and this flag appears whenever the radio noise is too much or the reflections are from the aircraft's body itself, and also if there is a loss of power. So we can say that the function of this warning flag is for the pilots to note that this radio altimeter is not working properly. So let's now look at the last part of the radio altimeter. Press to test button. So what is the function of this press to test button? So if we press this button, the pointer moves to a preset altitude. And this tests if the equipment is working properly or not. And it is also used to set low altitude warnings. So now we are going to study about the range and accuracy of the radio altimeter. So what is the operating range? We have seen before only that it works from 0 feet to 2500 feet above ground level. And its accuracy is plus minus 3% of indicated height or plus minus 1 foot, whichever is greater. You have to learn this because this comes in the exam. So for example, at 100 feet, it is about plus minus 3 feet error. And at 10 feet, 10 feet, it is plus minus 1 foot error. So now we are at the last part of the chapter. This is a very important and very interesting topic. So have you ever wondered why radio altimeter read exactly 0 at touchdown across different planes? So this is installation compensation. So because in different aircrafts, have different fuselage sizes. So if we compare the fuselage size of a 737 and 777, they are so much different, right? And also their landing gear heights, and also their cable lengths from antennas to avionics. So it all messes with signals, right? So how is it adjusted? Residual height, distance from antenna to wheels, and cable length, signal travel time in cables. So let me explain what happens here. So as you can see in this image, the aircraft is landing and the wheels are touching the ground, right? So it has touched down. So what this installation compensation is about is that they don't consider the height between the transmitter and the wheels. And thus in this attitude of the aircraft, at this touchdown, the radio altimeter will show us 0. And when the aircraft is at ground, meaning that it is parked, it may show negative altitude like minus 8 feet on Boeing 747. So what is the reason behind it being negative? So because the equipment is calibrated for the landing attitude and not the parking attitude. So if you compare the landing attitude with the parked attitude, you will get to know that the landing gear size is way longer in landing attitude than in parked attitude. And this is the reason when the aircraft is parked, it shows negative feet. So this is the end of the chapter. You can get these notes from the description itself. Thank you for watching.